So the next one's going to be finding the displacement, or finding your position after 5 seconds. So where you are after 5 seconds. So you just sub in 5 into the derivative, the displacement function, and you end up getting 20. What that means is at 5 seconds, imagine this is the house, you're going to be 20 meters to the right of the house. So the next thing we're going to figure out is the total distance traveled by the particle at the first 5 seconds. So total distance means the actual meters distance that you have traveled within the first 5 seconds. Now, total distance is not the same thing as displacement, because displacement just tells you where are you with respect to the house. So imagine what could possibly happen in the first 5 seconds is the following. So maybe the person within the first 3 or 4 seconds may have started here, moved back and forth, traveled very fast, and after 5 seconds ends up being here at that spot where we calculated. So who knows what's happening in between 5 seconds? And we need to investigate what happens to this person. Is the person standing or just to the left of here? We don't know where this person is and what's happening within those 5 seconds. So we're going to have to investigate what happens in 5 seconds. So to address the distance traveled within 5 seconds, let's figure out what happens at the beginning. So what happens at time 0 over here? Well, you sub in 0 into the position function and you end up getting 0. But what happens between, we do not know. Could it be like this or could it be like this? What is happening during this journey? So we found out from a previous calculation that something happens at 1 and 3 seconds when we found when the person or the particle is not moving. So the particle is not moving at 1 and 3, meaning there is no movement. And let's see what's the position at S at 1 and S at 3. So when I found the position at 1, you're at 4. So what that means is at 1 second, you are 4 meters to the right of the house. At 3 seconds, so let's try to make this as equal as possible, you're at 0. So that means you make it home. So keep in mind this is a cubic function and see what happens. So for a cubic function, just based on what we know about the behaviors and the leading coefficients, I know that the behavior of this function is going to be positive as I go to the right. As x goes to the right, then the y value will go up. So what's going to happen here right now is this graph is going to go up and then back down and then back up. So we're not going to include the arrows there because we are restricting our graph. So based on this graph that we have here, we can calculate by looking at each step of the distance traveled. So what that means is from here to here, the person traveled 4 meters. I'll put here 4 meters. But this person here after that decided to go home, go towards the house. From here to here, it's also 4 meters, even though it took the person a bit more longer time to travel. And afterwards, what happens here? Oh, the person is at home, but then what happens? The person goes away from the house and ends up at 20, meaning this person here is traveling between 20 meters. 20 meters. In other words, the total distance for each stage is going to be 4 plus 4 plus 20, which gives us 28 meters. So the person travels a total of distance of 28 meters. So for the next question, when is the particle speeding up? So speeding up means what? It means when the velocity is positive and the acceleration is positive, or when the velocity is negative and the acceleration is negative. So we already figured out the derivative of the velocity and the acceleration. So to solve for this, we're going to have to solve for inequalities. So let's figure out where the functions are 0 first, neutral, before we actually deal with the positive and negative. So let's set each equal to 0 and look for the zeros. So in this case, this would be t is equals to 2 for the acceleration. For this one here, I believe that we had this question before, t is equals to 1 and 3. So how are we going to set this up? So there's many ways to do this. I'm just going to show you one way. So one of the ways is to set up interval chart, where we put the zeros of the acceleration and velocity in order from smallest, which is 1, 2, and 3. And I'm going to make a note of on the left-hand side, create a column with V and A. And we know that for the velocity, if I go from here, that gives us a 0. For the 3, it also gives us a 0. So let's deal with the velocity first. So if you sub a number to the left of 1 into the velocity, you end up getting a positive number. To the right of 3, you get a positive number. And anywhere numbers between 1 or 2, any numbers between 1 and 3, you're going to get a negative. So I'm going to put all these negative numbers in here, negative signs, because I have space. So now what about the acceleration? Well, we know over here, I'm just going to draw a vertical line here, that this 2 comes from the 0 of the acceleration. But now let's actually sub in a number to the left of 2 into the acceleration. If you sub a number such as 1 into the acceleration here, you end up getting a negative number. So no matter what number you sub it in, you're going to accelerations for negative, and to the right, you're going to get positive. So clearly, we see that there is something going on with the signs. And now we can look at the overall, and let's look at the intervals right now. Well, if you notice here, in this area here, so I'm going to use yellow, notice how we have positive and negative. So in this area here, because velocity is positive, acceleration is negative, we know that we are going to be slowing down. Over here in the gray, notice how both these signs are negative, negative. So what that means is in these two intervals, that means you are speeding up. And over here, notice the signs here are negative, 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 but it's positive, positive, positive. So the signs here means, because acceleration and velocity are opposite signs, so you are slowing down. And the last one here, as you can see here, acceleration and velocity are both positive. That means you're speeding up. So to answer this question, we know that you're speeding up between two areas. So this area and this area. So in other words, you're speeding up between t is 1 and 2, and you're also speeding up to the greater than 3. Now, because I think we restricted this this graph here, meaning it's not always greater than 3, it's going to be after 3, but before 5. So let's have a look at the graphs of both displacement, velocity, and acceleration. So if you recall, the velocity is the derivative of the displacement, and the acceleration is the derivative of the velocity. So I want you to notice that there is a connection directly between all three of them. So what that means is velocity is, as I said, s prime or d prime, depending on what you want to call it. We know that acceleration is the derivative of the velocity. So just to put things in order from the actual original function, so to get velocity, you're going to find the derivative of from here to here. To find the acceleration, you're going to start from the velocity, get the derivative to get to the acceleration. So do you see the connection between the s and the a? So if the velocity is the first derivative of the displacement function, that means the acceleration is going to be the derivative and the derivative of the displacement function. And what that means is acceleration is the double derivative, or we'll call it the second derivative. Or we call it the following. This is first derivative, which we know is the same thing as velocity, but to have the second derivative, we just have to put in an extra slash here, meaning second derivative. And also just notice the way that the graph is functioning, these polynomials. So this is a cubic. So I'll put degree of 3. When we take the derivative using the power rule, it drops to a quadratic. And then we continue on with this. When we take the derivative of the parabola, the quadratic, we drop down to a linear. So here we have all the functions superimposing, overlapping each other. So the blue is the position. I'll call it D for displacement, V for the velocity or speed with a direction, and this green one is your acceleration. So if I were to give you 3 graphs overlapping each other, you should be able to figure out which is the original function, the derivative, and the second derivative. If you recall from our past activities, I asked you to do the art gallery where you were to figure out which is the derivative and which is the function. This is exactly the same. So I can ask you to analyze certain things about this graph here. So once you establish which one is the displacement and the velocity and acceleration, I can ask you some questions about it. For example, I can ask you what's going on at, for example, at 4 seconds. So let's look at 4 seconds. So what's the story at 4 seconds? So at 4 seconds, what does this mean? Okay, well, let's think of this as a house. So at 4 seconds in the displacement, you are positive. That means you are somewhere to the right of the house. Okay. Well, keep in mind going up to the red one here, I'll put a dot there. Well, what's happening? Your velocity is also positive. That means you're moving, you're not just standing there, you're actually moving towards the right. So this way you're going this way. So you're moving away from the house. All right. But how are you moving? Are you moving, are you speeding up, slowing down, or are you traveling at a constant speed? So now we're going to look at the acceleration over here at 4 seconds. Now acceleration is a positive. It's in the positive zone. So if acceleration is positive and your velocity is positive, what is happening to your motion here? Well, at 4 seconds, you're going to be speeding up. So that is the story at 4 seconds. Another question I ask you is, well, when do you change your mind in regards to direction? When do you go towards the right and then change your mind, move the left? Or the other way around, you're going left and then you change your mind and go to the right. So when that happens, there's many graphs that you can look. For example, you can look at the displacement. Maybe over here you can look at, because you're going up, you're going away from the house, and then you're going towards the house. So that could be a way to look at things. Or you can look at this one here. So meaning we can actually look at the turning points of the displacement. You don't really have to look at all 3 different graphs to answer certain questions. Or I can ask you, oh, when are you not moving? When is the velocity 0? In that case, you would focus on the velocity graph and looking for the zeros. In this case, you would look at the zeros of the velocities, and you can say, oh, at 1 second or at 3 seconds, the velocity is 0. So here's just a slide about the notation about first derivative and second derivative. You don't really have to read through the whole thing, but when you have a double apostrophe, it means the second derivative. Or if you use Leibniz notation, over here, this is the first derivative, all right? But then when you take the derivative of the derivative, you end up getting the second derivative. In other words, it's y double prime, or in this case we do d2y over dx squared. So these 2 numbers means the second derivative. We usually don't do third derivatives or fourth derivatives, but if you were to, it would look like this. So let's describe some of the object's motion given the first and second derivative. So if I say that st is equals to 0, meaning position is 0, this means you are at home. So over here, you're at the house. Now, when you are s prime is 0, what does that really mean? Well, it means that the velocity is going to be 0, meaning you're not moving at all. Now, this one here is s double prime. And what that means is it's not the velocity, but it's the derivative of the velocity, which we call is acceleration is 0. So that means there's no force being applied to your car, your moving car, or whatever it is. Now this one here to the right, well, your position is negative. That means you are to the left of the house. Now this one means your velocity is negative. That means you are moving to the left. It doesn't mean you're moving to the left of the house, you're just moving west. And this one here means your acceleration is negative. When acceleration is negative, you don't know whether you are slowing down or speeding up. It really depends on what you know about your velocity. In this case, we don't know anything about the velocity. So acceleration is negative, that's all you can say.